sides of a triangle have lengths of 4 and 11. The length of the third side must be greater than blank and less than blank.
The rule was you take 11 minus 4, which is what?
7.
7. That goes right here. And then 11 plus 4, which is?
15.
15. That goes right there. That's simple.
That's
Okay, the next one. Carson, go ahead and read.
In an isosceles triangle, each leg has length 9. The length of the base can be any number greater than something and less than something.
So normally I give you two numbers, but because I gave you as an isosceles triangle with the legs of 9, that means I really have 9 and 9. Same rule applies. What is 9 minus 9?
0.
That goes on the left. What is 9 plus 9?
18.
That goes on the right. So again, even though I gave you one value, if it's representing a leg, it is 2 9s at the same time. Okay, number 3. Iris, go ahead and read the instruction.
Determine if each set of numbers could represent the lengths of sides of a triangle.
Okay, if you kind of remember, it was you add the two smaller sides and has to be greater than the third. So 10 plus 20, is that bigger than 30?
No.
Nope. And then I have 5 plus 7 is what?
12.
Is that greater than 14?
That's
No. 6 plus 6.
12.
12, is that greater than 11?
Yes.
Yes, it is.
Greater, yes.
The next one, 8 plus 6, that is greater than 10? Yes.
Yes.
What about 4 plus 9?
No.
No.
Less than.
What about 1 plus 3?
No.
Also no, has to be greater than the third. Okay, next one. It says to name the angles. So these are my answers that I have to put in order from smallest to largest. So my smallest is number 3. So what angle is opposite of that?
B.
Angle B.
Yeah.
The next one is 5. What angle is opposite of that?
A.
Angle A. And that makes my third angle to be
C.
angle C. Okay, my next one, we're going conversely. This time we're going from shortest to longest, looking at my sides. So looking at my angle, 27 is my smallest, so what side is opposite? Y. Z, do we all see that? 68 is my next smallest angle, so my opposite side is X what?
XY.
XY. And the last one, without even looking at it, we know it's automatically XZ. XZ.
We're going crazy
Okay.
on this.
Let's move on to number 6. On number 6, I gave you the inequality. So really in the end, this becomes algebra 1. So it says AB, which is right here. So I'm going to write x plus 3. And move this over. And then it says plus AC. So plus AC is right here. Is greater than BC, which is right here. 3x plus 2, that's a 3. And then let's combine like terms. We have 2x plus 5 is greater than 3x plus 2. And I think I want to do two things at the same time. I want to move the 2x on both sides and then subtract 2 on both sides. That's going to cause the first one and the last one become a 0 pair. So I have remaining, it'll be 3 is greater than 3x. Is that 3x? I feel like I made a mistake. Oh, that should just be x, right? Because 3 minus 2. So if I were to write it in this manner, I'm going to completely reverse this. It'll be less than 3. Are we good on that one? Okay? Also on number 7, I gave you the inequality exactly like number 6. So my AB is 4x minus 2. My AC is 3x plus 1 must be greater than BC, which is 5x plus 7. When I combine like terms, how many x's on the left? 7. How many constant? Minus 1. It's greater than. I'm going to keep that alone. Again, let's do two things at the same time. Minus 5x, and then add 1. That's going to cost this one and this one to go. How many x's on my left remains?
2.
So 2x is greater than 8. And when I divide it by 2, we get what? X is greater than 4. Okay, now let's go on to number 8. Okay, on number 8, exactly how many can be found? Exactly 1. And that was on the quiz, right? So here I go. It says A, B, or C can be found, and I gave you a strict rule. Is 5 the same as 5? Then you can put a dot and say midpoint. Is 6 the same as 8? No, so I can't put a dot there. But is 7 the same as 7? Put a dot and say these two are congruent. When I connect, what line is it underlining? I mean, what letter is it underlining? B. So the rule is you take the parallel part, add them, and divide it by 2. So 6 plus 8, how many is that? 14 divided by 2? Done. Okay, for number 9, Reagan, go ahead and read, and you don't have to fill in the blank.
In the triangle, a perpendicular bisector is linked to a side of the triangle and intersects that side at its point.
Okay, it is perpendicular to the side of a triangle and it intersects at its midpoint. So to the midpoint in a perpendicular manner. Actually, that was already done, right? Dang it, we did number 9. That was already done. Okay, number 10. Let's see. Josue, go ahead and read number 10.
In a triangle, an angle bisector divides an angle into two congruent lines.
Is that true? If I give you an angle bisector, am I giving you 2 congruent angles? Yep. So congruent angles. Okay, Esther, going to read number 11.
In a triangle, a median connects a blank with the blank of the opposite side.
Drawing this image will be the best case scenario. So median goes from the vertex to the midpoint. That's our median. And maybe I want to highlight it. And you may as well. So we know median connects the vertex to the what? Midpoint. Very good. Vertex to the midpoint. Okay, Ruby number 12.
In a triangle, an altitude connects a blank with the line containing an opposite side and its blank to that line.
Okay, let's make another triangle. So altitude starts at the vertex and it goes straight down at a what degree? 90 degrees. So again, I'm going to highlight this to say this is representing my altitude. So that's going to be from vertex to the perpendicular side. And it's perpendicular to that line.